We're starting section 3.5, higher derivatives, Lagrange, review of Lagrange and Leibniz notation first, then detecting increase and decrease and concavity, higher derivatives, and implicit differentiation is the last thing we do. So notation for higher derivatives. We discussed this before, and so let's do it again. Lagrange notation is with primes. F prime of x is the first derivative, f double prime of x is the second derivative, f triple prime of x is the third derivative. After that, instead of putting more primes, we go in parentheses and the number of the number that the derivative is and the number of times we took the derivative. And so we parentheses and 4. And why parentheses? Otherwise it would look like f to the power 4. So f parentheses 4 is of x is the fourth derivative, and f to parentheses n of x is the nth derivative. And then the Leibniz notation, dy over dx is the first derivative with respect to x, d2y over dx squared is the second derivative of y with respect to x, d to the power 3y of dx to the third is the third derivative of y with respect to x, and d to the power n of y with over dxn is the nth derivative of y with respect to x. So what does it mean? Example, if f of x is x squared plus 3ln of x, then f prime of x is going to be equal to dy over dx, and so the Lagrange notation is f prime of x, and Leibniz notation is the dy dx. And so it would be derivative of x squared, which is 2x, plus 3 times natural log, derivative of natural log of x is x to the power negative 1. And so if I take the second derivative, it will be f double prime of x and d2y over dx squared. Derivative of 2x is 2. Derivative of 3x to the power negative 1 is going to be negative 1 times 3, which is negative 3, x to the power 1 less, x to the power negative 2. F triple prime of x, or the third derivative of y with respect to x, is going to be derivative of this, which is derivative of 2 is 0, and derivative of negative 3x squared, x to the power negative 2 is negative 2 times negative 3, x to the power negative 3, which is 6x to the power negative 3. And fourth derivative of x is going to be equal to derivative of 6x to the power negative 3, which is negative 3 times 6, negative 18, x to the power negative 4. I click here question 1. A piano falls out of a 4th-story window and plummets to earth, influenced only by gravity. Let h of t be the height of the piano as a function of time t. The third derivative of h of t is 0. True or false? And the answer is true, because the second derivative of h of t is the gravitational constant, and therefore and that's the acceleration of influenced by Earth, and so that's the third derivative should be 0. So A is the correct answer. So A is the correct answer. And why is that? Because what is it? H prime of t is the velocity. H double prime of t is the acceleration. And remember, acceleration is negative 9.8 meters per second squared. and derivative of a constant is 0. Again, h of t is negative 4.9 t squared plus v naught t plus h naught. Take the derivative of that and you get h prime of t equal to negative 9.8 t plus v naught. And you take the second derivative, you get negative 9.8. And then the third derivative is going to be 0. And all the derivatives after that are going to be 0 as well. Now, if p of x is a polynomial and n is greater than the degree of p of x, then p to parentheses n of x, which is the nth derivative of p, is equal to 0. So if you're taking the nth derivative, then n is bigger than the degree, it's going to be 0. So for example, derivative of 2020 d 2020 over dx 2020 of x to power 2005 minus 86 x to power 2001 minus 33 x to power 1984 minus 10 x to power 1066 plus 1974 x to power 105 minus 9378 is going to be 0. Why? Because the highest exponent of the polynomial is 2005, and so the degree of the polynomial is 2005. And when you take the 2005th derivative, you end up with a constant, and the next one is going to make it 0 and stay 0.